Alright guys, it's Miss Rizik and Mr. Kitcha here to give you guys some assistance on volume and surface area. So, as we discussed in class, there's 2D figures and 3D figures. 2D figures are usually just flat surfaces, so like a piece of paper, anything that you draw is considered a 2D surface. So for the outside links of the 2D surfaces, you always want to find the perimeter to figure out how big it is on the outside if we were to put up a fence or anything. And then on the inside, remember we said if we were laying carpet or putting down sod, then we would need to find the area of that figure. And we find the area by finding the length and the width. It's only 2 dimensions, so we're only multiplying 2 dimensions for our 2-dimensional figure, right? For 3-dimensional figures in the classroom, we discussed how finding the surface area for each of the individual shapes to add them all up. This was the cheat code that we came up with as a class for each face. There's also, don't forget to just, if you don't want to use the cheat code, then just make the list of, there was the front, there was the back, the left, the right, and like making those tables, and then finding the total surface area after you've found all the areas for each face, right? This is the face. For the inside, we're going to branch off into volume. So with 3-dimensional figures, once again, you want to multiply your 3 dimensions, the length, the width, the height. A very important thing that you guys need to kind of get outside of your head is that the names of each dimension will change. Some of us might call this the width, but others might call it the length, right? This might be the width, others might call it the length. This might be known as the height, but maybe others call it the length. It's very common for the names of each side to get misconstrued, right? To get rambled and bumbled. So you just have to make sure that you're multiplying each dimension of your figure, okay? Another way that we might have to find volume is by finding the base. So sometimes they'll give us the base and then one other dimension, whether that be the length, the width, the height, whatever it might look like. So like right here, it looks like we have to multiply the length. But on some of the Khan Academies, sometimes it will show different things that you have to multiply by. So I don't want you guys to get confused with the vocabulary in terms of what each part is called. Now, a little thing that I made was that showing, I've learned this on Math Antics actually. If we were to take our base figure, right, and extend it, pull it out, then we would get our 3-dimensional shapes, which was really cool. So we took our base and we basically slid it all the way up front. I know I'm not an artist, but I tried my best. And then that is just signifying how we turned a 2D figure into a 3D figure. I'll also post the Math Antics video as well. It's very lengthy, but it has like a lot of great information. So, digging into volume. As you guys see, I need music to help me focus. So, here we go. A suitcase is a rectangular prism whose dimensions are 1 1/4 feet by 1 3/4 feet by 1 1/4 foot. Find the volume of this suitcase. So, I went ahead and I created my suitcase. Now, it doesn't say which length, right, is 1 1/2 feet, 1 3/4, so you can just label them yourself. I'm going to label this one 1 1/4. This one should be longer, so I'm going to say that that is 1 3/4. And then this one will be our last length of 1 1/4. Now, I know that it's fractions, but how do we multiply fractions? Ooh, Miss Rizik, we multiply across. We multiply across. We multiply across. Right? So, I have, what are these called again? Oh, mixed numbers. So whenever we have mixed numbers, we have to get mad. So I have 1 1/4. Multiply the 4 times the 1, and that gives me 4. Plus 1 gives me 5/4. I'll bring it down here. So I have 5/4. Sorry for my handwriting, guys. And then I have 1 3/4. So I'm going to go ahead and convert that. 1 3/4. 4 times 1 is 4. Plus 3 is 7. Once again, we can find the volume, by multiplying all of our dimensions. So we have volume equals length times width times height. So I have 5/4 times, I'm going to write 5/4 again because we had 2 1 1/4. And then I'm going to multiply it by our final 1 3/4, which came to 7/4. And we multiply across. We multiply across. So 5 times 5 is 25. 25 times 7, we'll need a calculator for that. Just kidding. So here we go. We have 25 times 7, and we get 5 times 7 is 35. 3, it's really hard to do this one-handed, by the way. Okay, so 2 times 7 is 14, plus 3 is 17. So I have 175 over 4 times 4 is 16. 16 times 4, I don't know that off the top of your head. Off the top of my head, I should say. So I'm going to go ahead and create more workspace. I'm going to squeeze it up here. So I have 16 times 4. Oh, it's 64, right? 4, 24, so 4, 2, 64. I was right. Yay! Okay, now what does that mean? What is 175 over 64, right? That looks gross. Nobody wants to see that. So, once again, fractions, we divide in order to simplify. So, let me grab my handy dandy tissue eraser. And I'm just going to go ahead and divide. Be right back. Okay, so I cleared some space off. I reached the hard part of, okay, 64 cannot go into 1, 64 cannot go into 17, and I'm brought back to my 64 to 175. To save myself some time, I'm just going to use my handy dandy calculator. So, let's just type it in. So we have 165 divided by, oh, I'm sorry, 175. 175. Let's try again. 175 divided by 64. And that gives us 2.734. I'm just going to stop it at 0.73. So we have 2.73 feet cubed. Because we have 3 dimensions, right? We have feet by feet by feet. Feet times feet is feet squared. Feet squared times feet is feet cubed, right? 3 dimensions, our third exponent. Okay? Hopefully that wasn't too confusing. Don't mind my chaos. Y'all know how I like my chaos. Now, let's say that they give us a base, right? If they give us a base, then we need to multiply whatever our base is by the other figure present. So I made a rectangular prism again, and this face has the base of 15 halves, and we have the length or the width, whatever you want to base that off of, to be 6. Now, I have a fraction and I have a whole number. How do we turn fractions into whole number? You are 1000% correct. 608, 609, and 607. You are to put it over a 1. So I have 15 over 2 times my 6 over 1. Remember, this will be whatever the unit is squared. So this will be units squared. And this will just be the unit. So whether it be centimeters, this would be centimeters squared. If this is feet, this will be feet squared. If this is inches, inches squared, so on and so forth, okay? Because this, remember, is 2 of the dimensions being multiplied together already, okay? Now, I have 15 times 6. Looking at this, 15 times 6, I don't know it off the top of my head. So I have 15, sorry for the arm, times 6. And I get 30, I get 90. So I have 90 over 2 times 1. What is 2 times 1? Oh, I know, you're right, Jazeel, it's 2. So then I need to think, okay, well, I need to simplify this. So how can I simplify this? I divide, right? So 90 divided by 2, I know that by mental math. If you don't know it by mental math, that's perfectly fine. Just take a calculator and divide, or do it by longhand. But 90 divided by 2 is 45. So whatever is going to go inside, or I'm sorry, not whatever goes inside. This cube, rectangular prism, I apologize. This rectangular prism takes up 45 units cubed. So, say I was going to put this inside of a box, right? Say I was packing up something and I needed to figure out, okay, well, if each of these are 45 units, if it takes up 45 units, I need to figure out how many of these can fit inside of my big box.